All right, I'm just getting everything set up. Making sure I can see the chats. Okay, I can see everything now. So, we will be hacking a bit on a compiler I'm working on for language. And I've been doing some experiments, and now it's time to clean up a bit, now that things are starting to work. So let's just see what. Oops, I think I know the problem. One sec. Maybe I did not push the latest changes from my laptop, actually. One sec. So let me just check that I did actually push from the laptop. And I did. Okay. Maybe I didn't pull. Okay, well, let's try. That's better. Okay, let's record an intro. Is the camera lagging? No, okay. So I'll put a marker, I guess. Nope. How do I put a marker? Yeah. Oh my god. This Twitch UI often seems to break. Well, stream markers are just not working. Okay, so we're just gonna record a quick introduction. So, new window. I'm gonna do stream plan. Oh, I already had one. Okay, the plan. How's this look? Okay, so basically we want to first. Move hard-coded string lengths. Then refactor. Then start working on arrays. So that's the plan. And let me see. I might try and put this somewhere. Edit this. Yeah, okay. So we want that. And we can just edit this a bit. I think that works. Okay. So that's the plan. Okay. So the plan is we are going to, so I should give a proper intro. I've been working on getting, on a compiler for a language and a programming language. And it uses Rust, MLIR, and LLVM, and PEST, Rust crate for parsing. And this is kind of where we are at now. So we can have like simple structs, initiate them with strings, and we can call printf, and that's printf from the from the system's libc. And it kind of works with a few caveats. So if we run this program here, has to compile. You can see the printed output, it prints both strings, even though we only refer to the first field. And that's because the strings are not null delimited. And we packed the struct, so there's no space between. So when we give a pointer to the memory that starts here, printf will just keep reading the memory until it hits a null, an empty bit. Which is not really a bug, it's more of an interaction, let's say, with how printf works, and strings in C work versus our language right now. And we don't care about it too much just yet. So structs kind of work. And kind of overall, what the goal is now is to add like basic data types and then start implementing a proper type system on top of that, to have the basics down, and then do memory management and stuff like that. So there are a few hacks right now, which we will be ironing out this evening, hopefully. And as you can see, this is a big mess, the code base, because I've kind of been experimenting with how to get MLIR to work properly. If you're not familiar with MLIR, it's created by via the LLVM people, as far as I know. And it's basically a more flexible intermediate representation / compiler infrastructure that can be used for a variety of different things. We're currently using it in a pretty basic fashion to just output LLVM IR and then use LLVM to run our compile stuff to a binary or JIT. And that's fine for now. We just want to I wanted to try MLIR, and I want to have it kind of supported in the compiler because it has some interesting options when you're targeting different types of hardware. So say we wanted to target a GPU and maybe even run some code on a GPU and run on a CPU at the same time from the same program. MLIR, I believe, can help us with that. So that's why I'm kind of forced my way through getting MLIR to work. And hence this mess. So we need to start cleaning that up before moving forward. And the first place we are going to start is with these types here. So right now we can declare a struct type. So we're in the code generation part of the compiler. We can declare a struct type here. And the problem here is that we are just hard coding this to a string of length 2, which obviously doesn't make sense. So instead, we will, for now, I think, just make a function which accepts that's kind of weird, actually. This is wrong. No, it's not. It's not. So the problem here is we don't have types in our structs just yet in the struct declaration. So that is kind of a problem, actually, for us right now, because then we don't know how exactly we want to allocate things up front. So either we move things to the heap and go from there. Or we add type annotations. I think we'll add type annotations and we'll do some simple inference of them. So that will be interesting. So what we want here in our struct type is we want the name, and then we want a type, basically, like so. And we want a string type, probably. And in our string, well, we want two things. We want a string, and then we want a string literal. And the string literal needs to know the length up front. So we'll give that something like that. Okay. Yes. What's the problem here? Did we mess this up? Okay. Yeah. And then we should get a new error here. Yes. And for now, we're just gonna assume our struct fields are string literals to keep things simple. So when we want to figure out the type, or am I thinking about this incorrectly? Yeah, I'm thinking about this incorrectly. So we don't need this, I don't think. And we don't, no, we'll drop all this. Yeah, instead we want to look at initialization. So because basically when we declare the type, for now we're just going to say it's a struct, and every struct field has the type of a pointer to a string literal. And then it's when we allocate a struct that we look at the size and allocate it. So I was confusing myself a bit. So that means that we don't actually need to do this. Instead, our we'll call this field type will essentially just be a pointer, actually. So it will just be type okay pointer. Yes. Field type, there we go. Why did we mess up? Okay, and this should break when we run our program now. It should go horribly wrong. Or not. Ah, yeah, because we're not actually using this for anything yet. Yeah, okay. We're actually just hard coding the types. So, okay, but now we have this struct type. Yes. All right. And then we want to go to where we generate. So this is the field reference. We don't care about that just yet. We care about generating a struct. And we want to change this. Yeah, so here we extract our type, which should be correct. And now we don't actually care about these, I don't think. Yeah, so we allocate our struct. And here it's going to allocate just a struct with two fields that are just pointers. So that's all good. Why are we allocating that operation? Ah, yeah, okay. Okay, that makes sense. So far, so good. And then we're looking at the fields. And here, what we're doing is we are initializing each field. So we can actually see that if we do something like we emit the MLIR and then pipe it to translate MLIR to 1 sec. Translate to LLVM. And we don't want to run. We want to build our program and then emit MLIR. Oops. My God. Emit. There we go. So now we can see the LLVM generated by our program. And basically, we have allocated our pointer, and now what we're doing is we're going through each field, getting a pointer to it, and then storing a value. And this is what we want to change. So before we were storing actual strings in the struct, and now we're just gonna store a pointer to a string. So that's gonna mean a little extra work. Yeah. So we have are you not getting any music at all? It looks like you're not. That's a bit weird. Why are you not getting any music? No. There is no music on the stream. What? Why? Why? I cannot explain why that is happening. What if I open Chromium? Music. Player. Damn. There's really nothing else. Why? something. Okay, I think there's music now. We'll try with this, I guess. Okay. So. Yeah. So, yeah, as I was saying, we now want to essentially allocate a string separately and then load it. And what we're doing now is, yeah, we get the pointer. Yes. So actually, we might not have to change as much. If I have done my job correctly, we can just go over to the code generating the string. We can almost do that, because now what we get back is a pointer to the pointer to the string, and then we store the value that pointer points to. But actually we want to just store the pointer itself now. So let's just have a quick look at the language reference, so we just can remind ourselves of the operations. So, because what we're doing now is we are storing. And we don't want to do this. I'm actually a bit unsure if already doing what I want to do, because we get the pointer to an element. And we get the pointer to anonymous string. So was I just like confused before? Do we have the old output? If we do git stash and then okay, well, I feel like there's something a bit off here, but we had actually already switched to pointers. I just hadn't reloaded the code from the git pull. So we'll go back. It's just because the type of the pointer is not shown in the LLVM MLIR for some reason. I don't know why that information is, where that is lost. But either way, it doesn't really matter. Okay, well, that's nice in a sense. So we are already storing pointers to the string. Less work to change, let's say. But there are still hard-coded lengths. Is this actually used? And is this actually used? It is. So really we want to get rid of this. I think. Oh no, we want to keep that. And then we want this struct type. Struct type to be type store. Good. Struct ID. Yeah, okay. So if we run this now, should still work. That's interesting. We should already have declared our type at this point. LLVM type store, insert ID. I wonder what order we are traversing the nodes in. Well, we are doing it in the correct order. Let me see. So it's because there's a bug. No, there's not. Yes, there is. So if we did this, it'll work. Or what? Well, I guess not. But anyway, we are kind of missing a step because this is the ID of our struct. But the ID we are storing in the type store is kind of incorrect, which we can live with for now. We'll just adjust it. And that's again because there is no proper type annotations, which makes this a bit tricky. actually, it should be fine. And we have actually stored the information we need. Yeah. So what we can do instead is get can we? Because we have a type store here, and we have the LLVM type store there, but we don't have something from our value declaration from our assignment, saying what type it is. Okay, so if we go up to our assignment, the problem here is we don't really have the proper data structures to handle this yet. I'm trying to avoid implementing them right now. So in our variable store, we insert the ID of our assignment. So one thing we could do is insert, no, that won't work. That will not work. I guess we can just recreate the type here. Essentially, which is kind of ugly, but okay. Since that's all we have for the moment, we can just say this is the struct type. And no, we can't do that either. Okay, so we will need to do something more proper, let's say. So we will need a map from variables to the type ID. So let's just call this type. Let's just ID to ID. And then in our assignment, where did our assignment go? Here. We will God damn, this is cool. So we will generate our type. See, this is why you have all the different passes in a compiler. So you're not doing all this at once. Basically, we want to get the type of our expression. At least the type ID. For now is enough. So we want to do something like, well, let's type dot insert our ID, and then for now we can just if let TS expression does need to be some struct, then we have the type identifier, which is what we want, equals expression. We'll add it here. Yes. And then we will pass that along. Like so. To type. Yes. It's gonna be nice to refactor all this. Yeah, okay. And now we can say, delete all this and say our type ID is our struct ID here, and then our struct type is our LLVM type store dot get the type ID there we go, and our struct pointer is the LLVM value store dot get struct ID. Okay, now we should be good. I think we have to do like into or something here. And here we have to do like to what's wrong here. Okay, so that should be good. Now let's see if we run. Oh no. Type to clone. I don't think we want a reference here. Just cloning everything now. Why is that moved? It's moved here. Yeah. Okay. Now I really hope that at least runs. It did. Okay. We get our output here. We have some extra printing. Okay, nice. And onwards. So the next thing we want to fix is, okay, we'll just get rid of this. Yeah, so a struct field reference should be good now. Why are we not using the field ID? That's because we are not calculating. Okay, we're not completely done here. So we replace the struct type, but we do actually still need to calculate this. Yeah. Okay. Cool. So that works. And then onwards here. So we should be able to improve a bit. We get our pointer type. Yes. So now for the string type, we do not want a fixed. We don't want a fixed string type anymore. We want like a let string type. We want to return this. I'm just lazy, so I'm putting it. Yeah. So that would be our string type. We can get rid of that. Does this make sense? String type. That is space. Yeah. Okay. Get rid of that. And now we want to do the mapping. So we want to say, instead of this, we want to do fields dot iterator dot map f type actually. Collect. we can collect. I feel like there's something I'm missing here. Why? Ah, I know the problem. Okay. Let's say expression pointer. So this is going to be TS expression. God damn. Okay. Then we want to match on this. Let's say if this is a value, type string, it's the actual string. I want to do that. Otherwise, to do implementation. So now they should work right. What type is this? Type. Oops. Okay. Okay, we might have a problem. Let's see. So we have our struct type here, and we allocate it, and then we start filling out the fields. I'll just code it for now. Let's just check that everything still works. Seems to. It's not. Could potentially be a bug in there when we're not printing strings properly, but close enough. Okay. So we're no longer hard coding these structs. Very exciting. Now we go through the fields. Like so, we get the element pointer. Nice. Okay, I think that all looks about right. We generate the expression code, we generate anonymous string with the correct length. Awesome. I think this removes the hard-coded, most of the hard-coded types. Where did I put the checklist? Yeah. And that also means I might stop for today now, as it's getting kind of late and I need to sleep. And this is a good place to stop. This is nice. Very cool. Thanks for watching, and I'll see you again next time.